Hello, Mr. Austin here. We're going to take a look at lesson 4.5, solving equations with square roots. So one of the first things I think that's going to be super helpful is if we create a table of some square roots that we might be using. So let's do that first. Let's start with the most simplest square root we can think of. Obviously, the square root of 1 is 1, but the square root of 4, which is going to be our first one we look at, and that's going to go here. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. The square root of 49 is 7. I know these are hard to fit in the square roots, so bear with me here. The square root of 64 is 8. Square root of 81 is 9. Square root of 100. Having some trouble writing here. There we go. 100 is 10. The square root of 121 is 11. And then for when we get to some of the bigger ones, I think maybe we'll go ahead and list, I guess we can do at least 2 more for you. So let's do the square root of 169. Apologize, scratch that. That should be the square root of 144. That's our next one in line. Square root of 144. Well, if I can write it on here, it's not allowing me to write. Here we go, 144 is 12. And then the last one, square root of 169 is 13. Now, we're going to come back and look at this chart many a times. You'll use it on your notes a lot, but we're going to use these as we do factor trees and break down some things in our next page here. So let's take a look at that. So we're going to use that chart that we just filled out. And what we're going to do is we're going to use what I like to call a factor tree method to break down our square roots. That's how we simplify them. Here's how this works. The square root of 20 breaks into 2 pieces. Now, what I want to try to do is I want to go back and look at this chart. I want to try to find the largest square root number from this chart that divides into 20 evenly. And on that chart, the largest one that divides in evenly is 4. So I'm going to make the square root of 4 times the square root of 5. Since I know that 4 is the largest one, that tells me that the square root of 5 will not break down anymore. So the next row on my tree is the square root of 4 gives me 2. And then I know that the square root of 5 does not break down anymore, times the square root of 5. Therefore, the answer to the square root of 20 being simplified is 2 square roots of 5. Okay, let's use that same method for 24. So we're going to break it down. Again, we go back and look. Well, 4 goes into it. 9 doesn't. 16 doesn't. 25 is too big, so 4 must be it again. So I'm going to use the square root of 4. That's got to be times the square root of 6 because we've got to get 24, which tells me the square root of 6 will not break down anymore. This is the square root of 4 being 2 times the square root of 6. So the square root of 24 breaks down to 2 square roots of 6. For 108, as they get bigger, obviously, they become a little bit more difficult. I'm looking for 2 square roots that multiply together to give me 108. Again, go back to my list, and I've just got to check. Does 4 go into 108? Well, I can plug that in on my calculator. And again, if you're doing that, you're just 108 divided by 4 to see if it goes in evenly. And when you find out, it does. So 4 works. But again, since it's 108, I need to check others. So let's try my next one I run into. Does 108 divided by 9 come out evenly? It does. So 9 also works. So again, I want to test another one. I want to go to the next one, which is 16. 108 divided by 16. Does 16 go into 108? It does not. I get a decimal answer. So let's try our next one down. 25. Does 25 go into 108? It does not. I get a decimal answer. So my next one down is 36. Does 36 go into 108? It does. It goes in 3 times. And then if I would continue the test, you'll find out there's none. You get too big as you get down to 121. So we found out that our perfect square that's going to work is 36. 36 times 3. Telling me that 3 doesn't break down anymore. 36 is simply 6 times the square root of 3. So 6 square roots of 3 is what 108 simplifies to. All right, 275. As you can see, we're getting bigger. I'll go back to my list and test out. Does 4 go into 275? No. Does 9 go into 275? And again, all I'm doing is dividing my calculator to find out. No. Does 16 go into 275? No. Does 25 go into 275? Well, there's one that works. 275 divided by 25 is 11, which tells me I found it. It's the square root of 25 times the square root of 11. I know that 11 doesn't break down anymore, which tells me I found the biggest one. This becomes 5 times the square root of 11, which means it's simplifies to 5 square roots of 11. All right? So that's the method, the factor tree method, we're going to use for breaking down square roots. All right, let's take a look at what we're going to use those for. First of all, we got a couple properties we need to talk about. When you take and multiply two numbers together underneath the square root, I just want you to know that you can actually split those up separately into the square root of a times the square root of b. We'll see how this is going to help us later on. When you divide two numbers, you can also split those up into the square root of a divided by the square root of b. Okay? So let's take a look at our example that we have here. Our first example says the square root of 7 times the square root of 3, meaning that you could multiply those together as the square root of 21. Now, once I multiply those together, I want to quickly go back and check. I told you we would look at these and see, hey, can I break down the square root of 21? Well, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, and 25 is too big, which tells me the square root of 21 is as simple as it's going to get. All right, using my quotient, I can say, okay, the square root of 81 over the square root of 100. Well, first of all, I recognize right away that the square root of 81 is 9. And the square root of 100 is 10. So actually, my answer is 9/10. And that's it. 9/10 will not reduce down any further. Now, this last example is kind of interesting. You'll notice that this last example has a plus or minus sign right here. 8 plus or minus, we've not seen that before, the square root of 12 divided by 4. Okay, so this next problem looks a little bit different. Here's what I'm noticing. There's got a square root of 12 in there. So off to the side here, I'm going to try to figure out what the square root of 12 breaks up into using our same method. Well, that's the square root of 4 times the square root of 3. Don't really have to look over at my chart for that one. Meaning this is 2 square roots of 3. So that's what the square root of 12 actually is. So I'm going to rewrite this problem. I'm going to make it 8 plus or minus, meaning there's a positive and a negative answer. And then it is, oh, apologize, let me get rid of that. We just figured out it's 2 square roots of 3 for the square root of 12, all over 4. Now here's what that means. This is actually 8 over 4 plus or minus 2 over 4 square root of 3. So that means I can reduce the 8 over 4. That becomes 2 plus or minus. And then the 2 over 4 obviously is 1/2 times the square root of 3. Let me rewrite that plus sign because that looks awful. There you go. This is actually 2 answers. Just so you know, it's 2 plus 1/2 times the square root of 3 and 2 minus 1/2 times the square root of 3. That's where you get your 2 answers. Okay? All right, let's move on. Now we're going to start solving these. And again, we're using square roots. So when I see a problem that looks like this, I know that my goal has always been to try to get x by itself. Well, the question is then, how do I undo x squared? Well, to undo a squared, you use the square root. So this problem basically, we could take the square root of both sides. Now here's what you need to keep in mind. The square root of x squared is simply x, so we did get x by itself. Equals. Since it's the square root means there's two numbers that can multiply together to give you that 121. And if we were to quickly go back to our list here, we see 121. Oh, there it is, 121. It's 11 times 11. So let's go back to our problem, meaning this is positive 11 times 11 is 121, and negative 11 times negative 11 is 121. There's two answers, plus or minus 11. And the indicator for that is, you notice we have an x squared in the problem. That tells me there's going to be two answers. Next example. Well, first of all, I want to get x by itself, so let's subtract 5. That gives me 2x squared equals 36. Divide by 2. Gives me x squared equals 18. And then my last step would be to take the square root of both sides. Keeping in mind when I do this, I have to get an answer that's a plus or a minus. There's two of them. The square root of 18. So now I've got to break the square root of 18 up. I'm going to go off to the side here and do that. My list would tell me that the square root of 9 times the square root of 2 is what I want to use, because this is 3 square roots of 2. So that means x is going to equal, again, plus or minus 3 times the square root of 2. There's my two answers. The last one looks a little interesting because now we got grouping symbols. We're going to handle it the same way, though. I'm trying to get x by itself. First, I want to divide both sides by 2. That leaves me x plus 3, that quantity squared, equals 4. To get rid of that squared again, we got to square root the whole thing. So let's square root both sides. So that's going to leave me x plus 3 now. Got rid of the squared. Equals, don't forget it's plus or minus the square root of 4. Which, hang on, I know what the square root of 4 is. So it's actually x plus 3 equals plus or minus 2. Last step, getting x by itself, would be to subtract 3 from both sides. That means I've got x equals negative 3 plus or minus 2. And now I got to give you my two answers. Negative 3 plus 2 is negative 1. And negative 3 minus 2 is negative 5. There's our two answers for x. Okay, solving using square roots. That should be the end of this lesson. Good luck on your homework assignment.